Okay, so welcome everyone. Damian Rossney is our speaker tonight, and he is an early career developer and a career changer in Westchester, New York. Damian is a graduate of Skidmore College and Dev Bootcamp. He worked in the legal and nonprofit fields before turning to development full-time. He began using Hanami as part of his continuing journey to learn and apply Ruby and software development best practices, and is currently looking for a position and grateful for advice and leads. So with that, Damian, take it away.
So I want to thank Richard and the group for giving me this opportunity to speak today. He stole my first paragraph introducing myself, so I will just say that I am not a Hanami expert. I am just an early adopter and explorer. I've been using it to develop a personal project, and that's kind of what led to the experience that brought us here tonight. So tonight we're going to talk about Hanami and routing. Specifically, we're going to take a look at how my learning project in Hanami uncovered a bug in the Hanami Router component and how I worked with some friends to fix it. We're going to take a quick tour of the routing patterns and other Ruby frameworks like Sinatra and Roda and Rails and see how the Hanami Router implementation is different and I think in some ways better. We're going to talk a little bit about performance in Ruby libraries, specifically how some changes that I made to the Hanami Router led to a serious performance degradation, and then how we had to fix that. So Hanami is a full stack Ruby framework, similar to what the basic functionality provides, basic functionality of Rails provides. Hanami was created by Luca Guidi, an Italian developer. He originally called it Lotus, but had to change it for copyright issues, for trademark issues. So he relabeled it Hanami. Early versions of the framework really gained some traction, especially in Europe. They learned a lot as they went along, and by the time they reached version 1.3, they thought they had learned enough to decide that some breaking changes would be needed to move the project forward. So just to show you some of the people that are involved in these headshots down here, the third one is the third guy there is Luca. The first and second are, the first is Piotr Solnika, who's a Polish developer, and the second one is Tim Riley, who's a developer down in Australia. And the three of them have really been leading the project to develop the Hanami 2.0 version. So one of the first components that they revamped for Hanami 2.0 was the router, which was completely rewritten by Luca. And that's what we'll be talking about tonight. However, they kind of got bogged down in this effort. Open source is hard. And they really didn't make a breakthrough until I think Luca and Tim decided to take a more incremental approach. And so they decided to just work on and release one component at a time, even if that meant that Hanami 2.0 wouldn't be fully full stack for some time. During this process, actually, Luca decided to take a step back from his open source projects, and he named Tim Riley to become the Hanami project lead, which he is today. All right. So the story started for me last year when I decided to build out a product idea I'd had for some time. I'd recently discovered Hanami, and I was fascinated, by the vision and principles of the project. So I decided to build out my project with Hanami, in the reasoning that never learned better than I think you got to get. So that was me with Hanami, and I decided to build out my project. So I really love this kind of learning journey, and I wanted to find a way to contribute back to Hanami, but I had no idea where to start, and I really had no confidence that I could make an impact in a library like this. I'd never really made open source contributions before, just a few document, corrections and improvements. And by this time, actually, I contributed a couple of bug fixes to Hanami around their view helpers, that weren't creating correct HTML. But that's kind of a minor thing in my mind, whereas working on a library like this was very intimidating to me. So what I decided to do, because I really did want to make an impact there, I wanted to help, is that I decided to post on Hanami Discourse. And what I did was offer to pair with anyone anyone else that was looking for ways to contribute to the Hanami project. So I got exactly 2 responses to that. But one of them was from my friend Kyle Plum. So Kyle is a pretty accomplished JavaScript developer, and he's been occupying his spare time recently learning Ruby because he's been interested in it. And he also came across Hanami and had made a few contributions and was willing to collaborate. So we spoke and we seemed to hit it off, and we decided to leave it that we would brainstorm ideas for how we might be able to contribute to Hanami. And as it happens, it didn't take very long to find one. So this is the issue that I found in my project. So by the time I spoke to Kyle, I had just released my like super
Oh,
minimal
vaping's amazing. Vaping's amazing.
On my project, which really just consists of a search screen that can display a selected record. So the route configuration line for the display page look like this. And if you're familiar with Rails routing, this is going to look very familiar to you. The DSL for it is really almost identical. The only difference is in Rails, this would be a pound or hash symbol in place of this dotted period here. So I used a UUID in this route because it's a public facing route, and I didn't want to expose guessable IDs for this purpose. So this worked just fine. You know, my data model has a unique UUID field, so it's really just a substitute ID, so that I don't have to put my IDs in public. My next goal was to make an edit form that I would use to clean up the data that I had imported into my app. And this form was only intended to be used by me and would never be seen by the public. It was actually, I really only use it locally and haven't deployed it publicly. And this route looks like this. So the second one. So in this route, I use the actual ID because I'd be the only one that would ever see it. And it was helpful for me to know the ID in case I need to jump into pgadmin to make changes directly in the database. Since I was doing my data cleanup on a local database, I never had any plans to deploy this route. Unfortunately, when I put these 2 routes in like this, it didn't work. In fact, Hanami swore that the second route didn't exist. And I knew at this point that routers can be finicky, and that the order of routes can be significant. So I moved this route to the top of the route file, and it started working. And so that was good enough for me, and I got to work doing my data cleanup project. It was only a few days later when I noticed that the original route now no longer worked on my machine. So I swapped the order of the routes again, and show started working while edit disappeared again. So I had found a bug. I jumped over to the Hanami Router project repository and found a recent issue confirming the bug by another developer. So at that point, I reached out to Kyle and told him I thought we had found our opportunity to find a way to contribute to Hanami. So before I go any further, I just want to get some alignment on the language that I'm going to use here. I'm not suggesting that this language is like standard, but I need a way to distinguish between the routes that we define and the paths that come in from the public, you know, when our app is running. So this is like a simplified schema of a URL. And you can see it has 3 parts. The beginning part is the scheme, HTTP or HTTPS. The middle part is the domain, which here is www.example.com. And everything from that slash to the end is what is typically called the path. So we recall now that HTTP defines several methods of verbs that are used to categorize our HTTP requests. And so we're going to consider 5 of them in this talk. We're just going to talk about get, post, put, patch, and delete. And so all HTTP requests specify both a URL and an HTTP method. So for the remainder of this talk, I want you to assume that when I say use the term route, I'm referring to the combination of an HTTP method and a string as defined in our routes.rb config file. So, for example, these are 3 distinct routes. Even though they have the same route string, they use a different HTTP method. And when I use the term path, what I'm referring to is the combination of an HTTP method and the string that is passed into the router when our server receives an HTTP request. So these are 3 distinct paths that might come into our router. So the way we would receive them, we would be told that this is a GET request and that the path string is books 1, 2, 3. And finally, segments are the list of values that are separated by slashes in the string portions of the routes and paths. So if we see these routes on top, we look at the strings, the segments are books and the symbol ID. And in the paths, the segments for all 3 of these paths would be books and the value 1, 2, 3. So our segments would look like this. So next, what I want to do, I want to start by looking at routing in Sinatra, because Sinatra has a very simple approach to routing. Basically, this example from their docs tells you everything you need to know about Sinatra routing. All routes are defined as a method in code like this. And so the method name corresponds to the HTTP method. And then the route string is passed in as an argument. And if the route matches that method and that string, then the method yields to the block and executes this code. When I was in Bootcamp, one of my instructors described this as, he said, Sinatra is a DSL for routing HTTP requests to arbitrary code. And I remember at the time I had to look up almost every word in that sentence to understand what he meant. But that's basically what's happening here. And so your routing file in Sinatra would just be a list of these methods, just like this, calling out to whatever code needed to be executed for each of these incoming paths. The downfall of Sinatra, although it's nice in its simplicity, and it's nice in that it's defined purely in code. So there's no startup, delay when you run Sinatra. It just runs this code. Every route, every path that comes in is handed to this list of methods, and Sinatra just goes method to method to method until it finds one that matches. And if it goes all the way through the list, then it just returns a 404. The downfall of Sinatra is that these lists can get very long, and the router can be slow because any incoming request could potentially have to go through the entire list each time. So that's routing in Sinatra. Now, before I move on from Sinatra, I want to mention a library that was extracted at one point from Sinatra, and that's called Musterman. And Musterman is the library that's used, if we go back and look, that's used to parse the route that's defined in this method, hello/:name. And it allows Sinatra to identify this name symbol as a dynamic segment in the route and to pass that in, to provide that as a parameter to the code block here. And so Musterman was a nice achievement on the part of the Sinatra developers, and they extracted it because there was a lot of demand for other projects to use Musterman. And so it's widely used as a general purpose string matching library. And in fact, it's used by Rails itself in their router. So I just wanted to show how Musterman kind of works. You would pass in the string that represents your route, and you would create a new Musterman object. They typically call it a pattern. I call it a matcher. And so here, that's a triple equals. So if I create this matcher for books/ID, and I pass in just books, it's going to return false if I use triple equals to compare. If I use triple equals to compare it to the path books 1, 2, 3, it's going to return true because it's potentially a match. And then if I access the params method, it will and pass in the same path, then it will return me a hash that extracts the dynamic segments and assigns them to the proper key in this params hash. Does that make sense? All right. So before I move on any further, I just want to point out this very important statement from the Musterman docs. And I won't read it to you, but basically it's telling you that Musterman is designed to front load all of its computation. So creating a Musterman matcher is expensive, whereas using one is very fast. Right. So let's move on to the next framework, which is Roda. So this is Roda routing. Roda is an interesting library. It's maintained by a guy named Jeremy Evans, who's really one of the luminaries in the Ruby field. And he maintains a ton of libraries, and this is one of them. He doesn't say that he created this one because he originally forked it from another project called Cuba, and Cuba still exists, but he wanted to take it in a particular direction. So he forked Cuba, named it Roda, and he's done a lot of work to make it really fast. What's different from Roda compared to Sinatra is that Roda uses this routing tree. So rather than having a linear list of routes, routes can be nested based on the path segments that they match to. So this is the example that we're looking at where the first route here is designed to match to the root, right? So if you just go to the domain with no additional path, this is this method r.root will match to that and will, in this case, return the index view, which I guess would be what we would expect. And what's happening in this next block is they're using the r-on method. And what they're doing is asking that this method receives the incoming path string. And so these arguments, artist and integer, are asking the router, does this path string start with the word artist and is the next segment an integer? And if so, then we want to yield to the containing block here. And that integer segment is then yielded as this local variable artist ID, right? And so what Jeremy says about that he likes most about Roda is that even though he hasn't completely matched the route yet, you can start working while the routing is still in flight. And so what he's showing here in this example is that an instant variable is being created and it's assigned, presumably this is reading from the database an artist based on the artist ID that's been passed in, and then calling a check access method on that artist, right, on that resulting object to see, presumably to see if they have access any further. Now, at this point, the complete route has not been matched because we haven't matched to a verb. So the next thing that Roda does here is he uses the r-is method to ask if this is a complete match. In other words, we know that that artist and integer match the first two segments of the incoming path, but is asking, are there any remaining segments? If there's no remaining segments, then this is a complete match and I want to execute the code within this block. And at that point, we have different blocks that ask whether or not the incoming path uses a get method or a post method, and we have different code to execute for each of those code paths. Now, this was the most code that I could fit on a slide, so I didn't want to show any deeper nesting. But what you could also do is immediately following this r.on call, this r.on call, is you could have another r.on or r.is call asking if matching against any subsequent segments that might be in an incoming path. So what you end up with in code is this kind of tree-shaped structure that gets deeper based on the number of segments that it's matching against. So again, one of the advantages of Roda, like Sinatra, is that the routing tree, as Jeremy Evans calls it, is defined in code. There is no compilation of this router, it's just executed. So when a request comes in, the path is past this router, and the router just goes ahead and operates on it. Because it's a tree rather than a linear list, it's also faster than Sinatra. In fact, I think Roda is really the gold standard for speed in Ruby routing libraries. All right. So let's look now at Rails routing. So I'm not going to go into the really technical details of Rails routing, like under the hood, because I don't know them. But I do want to point out some of the characteristics. So for illustration here, I have the 7 RESTful routes, and how they would be defined individually in Rails. So these are the lines that you could put directly into your routes.rb config file. And I wanted to show these to compare them to the process of doing the same thing in Roda. I think that the beauty of the Rails approach is the developer experience. I find this very easy to read and understand and to manage, over a long period of time. In fact, you don't even have to specify these 7 individually. Rails has shortcuts where you can just say resources or resource users, and it will define all 7 of these routes for you. So even though this feels more like configuration, I find this to be a smoother developer experience than either Sinatra or Roda. Another difference between Rails and Sinatra and Roda is that Rails requires a startup time. So this is code, just like Sinatra and Roda, but the difference is this code is only run at startup time. So these gets and posts and patch and delete that you see here are method calls, and the strings and symbols that you see here are the arguments to those method calls. So the way that Rails works is on startup, it processes your routes file, it reads each one of these lines, it executes these methods, and it builds a data structure in memory. Now, I've heard a talk by Aaron Patterson. He referred to this data structure as a state machine, but I don't really understand what he means by that in this context. The important thing to know is just that the Rails router does require compilation at startup time. Now, the other thing that I want to note about Rails is that it also uses Musterman under the hood to actually match incoming paths to these defined routes. And so the Rails implementation of Musterman also allowed you to specify constraints on any of the dynamic segments in the routes. So if it's not clear, I do want to be clear what I'm talking about dynamic segments is these routes are made up of what you might call static segments and dynamic segments. And so the static segments are the plain words here, users or new or edit, and those are always going to be the same on the incoming routes, whereas ID is a dynamic segment. So basically we're asking Rails to, if it sees a incoming path that matches this pattern of users slash something, that it capture that something and return it to us as a parameter that we want labeled ID. And so we have dynamic segments defined as straight text. Static segments defined as straight text, and dynamic segments defined as what looks like symbols in our strings here. Another thing that the Rails implementation of Musterman allows you to do is to specify constraints on the dynamic segment. So this route down on the bottom here is using a regular expression to specify that ID must consist only of integers, of numbers. So if we received a route that was /users/ABC, it would not match this route because it would not match this constraint. Even though the pattern matches what we have specified in the string, it doesn't satisfy the constraint. Right. So now I want to start to shift the conversation over to the Hanami router and how that works. And the Hanami router is built around an unusual data structure called a trie. And we're going to pause here and talk about what a trie is. So first, a note on pronunciation. The term trie, T-R-I-E, was coined by a computer scientist named Edward Fredkin in 1960. He chose that label or that term because it's supposed to represent the middle syllable of the word retrieval. So the TRE in the middle of retrieval. He liked to pronounce this word as tree, but personally, I think that's cruel and a bit diabolical. So I follow the example of most other people, and I pronounce it as trie in order to distinguish it from other data structures like trees. So how does a trie work? So imagine that you want to create a program to check if a word exists in English. So your first approach might be to start by compiling a list of all valid words, or finding one on the internet, and then to check if a word was a valid English word, you could then go through that list, comparing your word to each of the entries. So you'd either find the word or you travel all the way through the list and declare that the word doesn't exist. But this process is not only slow, but it's inefficient. And one of the ways it's inefficient is that your dictionary contains many redundant letter combinations in similar word entries. So this is where a trie data structure could come in. What this image shows is an excerpt of a dictionary created as a trie. So from this diagram, we can see that the dictionary trie contains nodes representing a single letter. So each node may contain a list of possible letters that follow the current node or letter. And then they may also contain a flag indicating that the current node represents a complete word. So here, a complete word is indicated by a double circle. So let's take a look at it. So we start at the root, and the root would contain a collection of all of the letters in the alphabet, right? Because all of the letters of the alphabet can start a valid English word. And we see that A by itself is a word. So it has a double circle. So we're just going to look down now at this excerpt for C, and we see that starting at C, we can see a word defined here. C and A is not a word, right? It's not, it doesn't have a double circle, but CAP is a word, as is CAPE. Likewise, CAT is a word, and so we have a double circle around T. Finally, CB maybe is a word, maybe it stands for the abbreviation for CB radios. So we can see which of these nodes represent a word and which don't. And it's simple to read across the nodes to identify our word. So the nice thing about a trie data structure like this is even if you can't compile it once and store it, even if you have to compile it from scratch, it's pretty fast to create. You just take each word, split it out into the letters, and pass each letter in turn into the trie. And the trie, so if I was going to store the word cape, the trie would receive the first letter, and direct us to the collection for C. We would receive the second letter A and move down, and so there is a node for A. And let's say that I'm going to do the word cats, right? So I'm going to find the C first, then the A. These are nodes that already exist. I'm going to find the T node, but I also now want an S node. So the trie would then create the S node and place the flag on it, place a double circle around it to show that that word also exists. And that's a fast process because once you get going, most of the nodes have already been created. So you're just navigating down your trie and creating individual nodes as they're needed. And likewise, tries are very fast to read from and just following the same pattern. But again, the only drawback then is the startup penalty to build this trie in memory if it can't be stored in a compiled state. But you can see that the storage efficiency of the trie is also very good because you don't have to repeat redundant letter combinations that are shared between similar words. So how can this be used to help us build a router? Well, what if we imagine that each of these nodes, instead of representing a letter, represents a route segment? So a routing tree like this could be very efficient, especially since routes like words contain many redundant node combinations. So let's take a look at how this is used in Hanami. So finally, we're going to get to the Hanami router. So this is just the Hanami representation of the 7 RESTful routes. And the only difference between this, again, and the Rails representation is the argument passed to the 2, which in Hanami uses periods to separate what you would call a controller name and the action, whereas Rails uses a pound sign or a hash sign. So if we look at these 7 RESTful routes, there's a few things that we notice about them. The first the first 3 are really static routes, right? They don't have a dynamic segment at all. And the remaining 4 are what you might call dynamic routes because they contain a dynamic segment, at least one dynamic segment. And so the way that the Hanami router works is to create a trie, and the first level of the trie, the first set of nodes, is the HTTP method. And then below that, there will be more nodes based on the segments defined in the routes definition file. Let's see what that might look like. So first, we're going to look just at the dynamic routes, just to keep it simpler. So in this case, we have 3 methods that are used: get, patch, and delete in the RESTful routes. And in the get path, we can see that there is a get users ID route, and we know that it ends there because of the circle. And there is also a get users ID edit route. And so there's 2 complete routes along that branch. On the patch branch, there's only 1 route. It is patch users ID. And on the delete branch, we only have users ID. So I wanted to start here because the next one is busier with all 7 routes. So what happens if we add back in the static routes? So then our routing tree starts to look like this. So again, when creating the route, when reading in the route specifications from the file at startup time, Hanami is going to build this structure by first looking at the method and sorting into method buckets like this. And then it's going to break down the segments, and each segment is going to become a node. And if that node is the final end of a route, we call that a leaf. So that node is also a leaf, and the leaves here are designated by a double circle. Now, one difference from this implementation, between this implementation and the simple dictionary example that I showed before, is that each of these nodes, for this purpose, contains 2 collections. It has represented by Ruby hashes. So it'll have one collection for for all the child nodes of the parent node that are static segments, and a separate collection for dynamic segments. Right, so this users node at the top has 2 collections. One of them has this ID segment in it as a symbol, and the other has new. Now, on the static collection, the way that we structure it is that new is the key for this entry in the hash, in the static hash, and the value is this new node itself, right? So users would use the new label to find the new node in the static hash. But in the dynamic collection, instead of using this symbol, what the Hanami router does is it actually creates a musterman matcher for this specific segment, and that matcher itself is the key in this hash. And again, the value is the node itself. And the way that the router works when you pass in a path is that it matches first on the method, and then if the next segment is users, then we have a match to this node. And then if the next segment is a static segment, it'll look in the static collection, and if it matches this node, then it'll continue down that path. If it doesn't match any entry in the static collection, then it asks each of the dynamic nodes in turn, does this segment match your matcher? And if it does, then it continues down to that node. So this is what the musterman matcher would look like for one of those individual segments. You see, it's just one item. And this is different than the earlier musterman example where it was created using a full route string. So rather than pass in the full route string, this Hanami router is using a musterman matcher only for individual segments. So let's look at an example then visually of how the matching works in this with the Hanami router. So we are going to parse this incoming path. So we're going to parse this incoming path, and I'm going to describe the process for you, and then I'm going to show you a visual representation. So first we would match the get method. Then we would look for a static node defined as users. Then we would look for a static node defined as 1, 2, 3. And if we don't find that, we look into the dynamic node collection and ask if 1, 2, 3 would match any of those matches. If it does, one of the things that Hanami does is it stops here and it starts to collect a parameter hash. And that parameter hash will be populated by using the original label created, the symbol that was created in the musterman matcher, that was used in the musterman matcher, and a value of the incoming segment. And finally, we would then see if the last static segment matches edit. So that's the process that we would go through here. And if we were successful, then we would also be returned a params hash with all of the parameters that are extracted from the incoming path. So let's look at that visually. I think it's easier to understand here. So this is our route that we start with at the top, and we're using this routing tree, the simplified routing tree that I started with. So when we look at the get segment, that brings us to the get node. Next, we're going to break up the routing string into segments. So the first segment of that is users, and that matches this node. The second segment is 1, 2, 3, which matches the ID matcher. And the final segment is the edit static segment, which brings us to this final route. And so what this node then holds, and that is returned to the router, is the name of the action that that we defined to be run for this path. So at this point, edit would return the user's edit action, and the router could pass off control to that action. So again, there's kind of two crucial facts that we want to remember about this process. And the first is that the Hanami 2.0 router collects dynamic segments by building a params hash as it goes, matching down the trie. This is not a bad thing, but it's important to remember. Second is that the Hanami 2.0 router only uses Musterman to match individual dynamic segments and not to process the whole route in the same way that Rails and Sinatra do. And so the beauty of this approach is its speed. While it's not quite as fast as Roda in all applications, it is much faster than Rails or Sinatra, and also manages to maintain full parity with the developer experience of Rails routing. The only problem is that bug. So let's get back to our bug. So if you remember, these are the two routes that didn't work for me in combination. Whenever I tried to run this, whichever route I placed second would never be reachable. Changing the order of the routes did not change this. Whatever was defined last just wouldn't work. And the problem is that the Hanami 2.0 router would build these two routes into a trie that looks like this. Oh, I just wanted an example of how this would not work. So if I had the routes defined in this order, and I passed in this path, clearly you and I can see that this is authors followed by a UUID. The problem is that Hanami can't tell the difference between an ID and a UUID. All it knows is that anything that falls in that segment location is going to be assigned to this symbol. So what would happen if this was passed in is Hanami would match the get method. It would then match the author static segment, and it would then incorrectly match this value to ID. So it would assign in the params hash the key ID with the value of this UUID, but then since there was no more segments to match and ID doesn't indicate here a complete route, Hanami Router would say that this does not match this route and would return a 404. The problem is that it could not at that point then go back and check whether or not the same path might match authors / UUID. And the reason is that the trie that it constructs looks like this. So when it follows down the matching path, it matches get, it matches authors, but it can't tell the difference between ID and UUID. As far as the router is concerned, anything that's contained in that segment matches ID or UUID. So since ID comes first, it matches there. But since ID is not a leaf node, you don't have a complete match, and the router returns a failure, which for the user is a 404. Since this is a trie data structure, it doesn't have the ability to backtrack and go down a different path. In fact, that would be contrary to the design of a trie. Tries are designed to be like, damn the engines, full speed ahead, we're going to match all the way or not at all. And so there's no concept of like, a breadth first search or a depth first search where we search through the whole tree, because that's a much slower algorithm. So what happens here is the second route always fails. And if I reverse this so that ID was on the bottom, then my UUID route would work, but the ID edit routes would be wrongfully, incorrectly matched at that node level to UUID. And then when the incoming path asks if there is also an edit node following UUID, the router would say, no, of course there isn't, and would again return a 404. Does this make sense? I just want a sanity check to make sure that I'm not losing anybody. Oh. So this is our bug. So how did we fix this? So Kyle jumped right in on this, which I was very grateful for. And he dove right in and started looking at Musterman and what it did. I had never heard of Musterman before that, or maybe I'd heard the name, but I had no idea what it really did. And this was all a black box to me. So it was very helpful to be paired with somebody that would that was willing to dive right in and take me along with them. So I appreciate that. So let's look at the way that we decided to fix this. So believe it or not, after all of this setup, the fix from this was actually fairly straightforward. And the answer that we came up with is that when we're structuring our trie, when we're creating our trie, rather than create separate nodes for dynamic segments, as you see here for ID and UUID, we're going to combine all of those. So rather than have a collection of dynamic segments, this author node, the parent node, would have a single dynamic node. And so, and that would then contain any child nodes, which in this case, you see there's one static node as a child node. And so this is a catch-all dynamic segment. So now when we're constructing our routes, any dynamic segments, no matter what their label is, no matter what they're doing, they're just going to be assigned to this one node. And what we're going to do is we're going to defer our matching until we've determined that we have a complete potential path match. So if we have a complete match to our path, then at that point we check and see if the values that were received at the level of this dynamic node are a match for any of the matchers in our tree. So the way that the previous router worked is that leaf nodes would store the action that we want to go to. And what we're going to do here is in addition to that, in the leaf node, we're going to store the complete route that could match this leaf node. And that means that a leaf node could potentially have more than one matcher in it. It's possible for there to be different dynamic segments that define different routes, but they end up on the same node. So now the leaf node, which here is edit, has a list in it, a collection in it of all the potential routes that it could match. And the way that we implemented this is that if we had a potential match all the way to this leaf, at that point, we would take that complete route, create a musterman matcher, and evaluate the path against that matcher. And so it would return true or false to say if it was a match, and if it was a match, it would also parse out our parameters for us. So this is different from the original router in several ways. We're combining all of the dynamic collections into a single dynamic node at each, potentially for each node that has dynamic child nodes. We are not collecting parameters as we go through the nodes, as we navigate down the trie. Instead, we're deferring both the matching and the parameter extraction to as an end check on the incoming path. And so this worked. This is the way we implemented it. All right, so when we match to a leaf node, we then go through our list in order of matchers, and if the first one that matches, we stop there. That's the route. We extract our parameters, and we return the action that needs to be run at that point, and passing the extracted parameters to that action. So if none of those matchers match, then at that point we return a 404, just like before. So with these changes merged, the bug was fixed, and the fix was actually included in the Hanami Router 2.2 release. So this is the code that's in the wild now. So our epilogue is how I killed Hanami Router performance. I want to draw your attention to this passage, this very unfortunate, reckless, and I would say arrogant passage that I included in the pull request that I wrote to merge our code. And while I believed these statements were true, at the time that I wrote them, putting them here was purely speculative and ill-advised. And sure enough, on New Year's Eve, no less, I received notification of this issue in the Hanami repo. I had broken the Hanami router. And if you look in the table down at the bottom, you will see that for sample apps with 1,000 routes, the changes we made to the Hanami router made it 50% as fast. And if the sample app contained 10,000 routes, our performance dropped all the way down to 1/15 of the previous router's speed. So suffice to say, I did not have a happy New Year. So luckily, the solution for this became obvious once we came back to that critical passage in the Musterman docs. And what the message was that I missed here when I read this is Musterman wants you to create matchers up front. They should be created at compile time, not lazily, as I thought, where I believe that lazily creating the Musterman matchers was smart, would be an improvement. It's actually contrary to their design. So the solution here was, rather than storing the route in a leaf, what we did when we compiled the routing tree was to create and store the Musterman matcher itself. So all the Musterman matchers would be created ahead of time and would be used directly when matching in a leaf. And that one change alone brought us back pretty much to on par with the previous router, but we were also able to make one other optimization around the way that I chose to split route and path strings into segments. And for some reason, I decided to do it using a regular expression, searching for the hash character, and that's actually way slower than just using a character-based split method on the string. So those two changes were enough to bring us back in par with the 2.0 router. And actually, I think in the end, we were a little bit faster. The drawback, however, was that we were creating now many more Musterman matchers up front. And so the trade-off for this was a much slower starting time. And so that's an issue that we're working on now. And unfortunately, we haven't closed this pull request yet. We haven't merged it. So we haven't gotten that speed correction out to the public just yet. But that is the story of how we found a bug in the Hanami router, how we fixed the bug, killed performance, and then brought it back to life. That's what I have.
Really enjoyed that. Thank you so much. I apologize to everyone that we had all of those interruptions. I can't believe people still do that, but it hasn't happened to us for a long time. And I was kind of shocked. So I stopped admitting people because of it. And although Alex just joined us, he was kind enough to send me his LinkedIn site so I could see that he was a real person. But so sorry for those interruptions, Damian.
No problem at all. Those are perils of running, open meetings.
Yeah.
Like everything else.
Although I think we're going to make some adjustments because I would like not to experience that again. But it's really interesting. So I was in the process of kind of monitoring things, and I believe I caught all the salient points. One question I did have, and I apologize if you already explained this in your talk, but when you made that adjustment to how you process the trie, so you got the match, and then once you had the match, you then did another matching process through Musterman, or can you just clarify that a little bit for me? I'm not sure if I picked
With the
up on that
improvement here,
subtlety. Yeah. So you got this fixed the bug, and then once you made this match, how did you differentiate, the two paths of
sure.
uh, ID edit versus I forget what the two options were.
Sure. So the two paths that we had trouble with were these. So you have the first one has 3 segments and the second one has only 2. And so when we try to match the first segment, we match the method, we match the static segment authors. We then find we're then trying to match, let's say the incoming path is author /123/edit. So the second segment that we're trying to match is 123. There is no static segment with the key 123. So we presume at this point that it's going to be a dynamic segment. So the first question is, does authors have a dynamic node? And it does. So we just accept that that's a dynamic segment and continue to parse the path. And so the remaining segment in the path is edit. And at that point, we have completely consumed the incoming path. And so the router asks edit, since it has no more segments to pass, are you a leaf? And edit says yes. And so edit at this point will compare, when we built the router, edit node, received the Mustermann matcher for the complete route. So it's a Mustermann matcher built on the string authors/ID/edit, right? With ID being a dynamic segment. And so edit holds this Mustermann matcher in its collection, in its leaf collection. And so when the router asks it if it is a final node in a route, it passes the full path into each of the matchers in its collection, which in this case is only one, and that returns true. So it knows that it's a complete match. It returns the parameters and it returns the action that's specified to run.
That makes sense. And then when you don't have the edit, that's also a leaf, considered a leaf, and
Right.
Similarly, you do the same process for the patterns that are available. Perfect thing. That's very clear. So go ahead. Charles and Joe, say that again.
I was going to complete the explanation. So if you received an author/UUID type path, with a 40 character UUID or whatever it is, it would likewise match get and authors, and it would match the dynamic node. And at that point, the router would ask the dynamic node, are you a leaf? It would contain just that one matcher of author/UUID. And so it would return true. It would return the UUID as a parameter. And again, it would return the action that needs to be executed at that point.
That's very clear. Thank you, sir. Charles, please go. And I think Joe had his hand up too.
I was going to say, Joe, if you want to go first, because I know you raised your hand before me.
Oh, it's fine. I guess one thought I had was, I guess originally, could you have just fixed it with a constraint? Is that something that was available in Hanami? But like, I could see the flexibility that you're adding would be convenient as well. But just a thought I had.
Yeah, it absolutely is a possibility. That would be the workaround. And honestly, I forgot to mention that. But in the same way that in Rails, you are able to define a constraint here on the bottom of this slide, we could have done the same thing and defined a constraint. So I'm glad you asked that question, because it's really a little a detail that I should have delved into further. And that's the drawback of using a Mustermann matcher for a single segment. So using a Mustermann matcher like this really kind of defeats the purpose of Mustermann, where Mustermann strength is matching long complex strings and extracting information out of them. In fact, it can also do the reverse, where you can provide a matcher and some parameters, and it will generate the string that you're looking for. And I believe Rails uses that to generate links, right? So when you say for this path with these parameters, give me a link, Rails is using Musterman to do that also. But when you use Musterman to just match a single segment like this without any additional constraints, you're really returning an object that'll match anything, which means you don't need to use Musterman at all. You're just saying that whatever is there, give it to me with this label. And there's no reason to use Musterman to do that. And so using Musterman in this way without constraints, I think is unnecessary. But using a constraint here, so let's look at the two routes. If we had added a constraint to the first route and just used our regular expression specifying integers, that would have fixed the problem. That would have totally fixed the problem, and that's a standalone solution. However, I would argue that it's still a bug and should still be fixed because there are other use cases in the wild where you might have different dynamic segments at the same level, you know, of a path or route. Did that answer your question?
Cool. I guess I
Yeah,
can go
that
then.
answers it. Thank you.
This is a really cool talk. Thank you for walking us through. It was really fun to like watch you explain the bug. I have two questions. I think the first of which will be really easy. You mentioned that at every node in the tree, we store two collections, one for static and one for dynamic routes. And I think I was wondering why we have two collections rather than one. I think maybe it's so that static routes can override dynamic ones. You mentioned like,
Yeah.
sorry, go on.
No, you're right on point. The way that Hanami works, and one of the things that makes it faster is that it always tries, it always tests a given segment against the static collection first. And that means if there's a match, if there's a static match, then a similar route with an integer at the same level would never be able to match that static segment, right? So if we have like some kind of slug here, I'm looking at the top set of nodes here on the get path, and you can see that the user's node is the parent, and it has a static collection that here only has the node new, and it has a dynamic collection which here only has the node ID with that symbol. So they have to be kept separate so that static segments can be checked first. And only if that fails, and again, this is the previous router, only if that fails would we then check for in the dynamic collection for a node that could match that segment. Again, the downfall is that it can't tell the difference between ID and UUID when it's trying to match potentially more than one dynamic node. And so again, our solution was to not have a dynamic collection, but to simply have a dynamic node. And so any dynamic segments at that level all flow through that one node. We don't care what it is. We don't care if it's an ID or a UUID. We'll check that if and only if we have a complete matching path at the end. And at that point, we use the Musterman matcher for the full route to determine if there's a match. And if there is a match, then apply the dynamic label that's in that route, right? Does that make sense?
Yeah, totally. And I think actually you've answered my second question, so I appreciate it.
Okay.
That must have been kind of surprising to find this bug. And, you know, I guess it's been there for a long time, you know, that you guys, probably other
Yeah.
people ran across it and just had, you know, just accepted it. Oh, this doesn't work this way. I'll just do it this way or something. You guys
Well,
actually fixed it.
There was, when I checked, at least two issues that had been opened around this bug. And one of them was maybe a year previously, and the person that opened it said they, you know, they took a look, they didn't have time to really dig in deeper and didn't have a quick solution. When I ran into this, somebody had just opened an issue like within a few days. As I recollect, it wasn't very long before I ran into this. And so I jumped in on that issue, with whatever insight I had at that point, which I had not looked at the code yet, so I didn't have an answer. Once Kyle and I jumped into the code and looked at the way that muster man was being used, I had to go and, read an article on the trie data structure, to understand it. I found a nice Ruby example online. Another name for the trie data structure is a prefix tree. So the one that I found was actually using that term. And so then armed with the knowledge of how musterman worked and the basic understanding of what a trie was, and then looking at the implementation, what I actually did, I wonder, let me see. What I actually did was start opening up the whole router object that's produced, so I put in a basic routing file and then went into IRB and looked at the resulting router object. And it started to become clear very quickly that that the trie was never going to work, in that configuration. It would never reach the second dynamic segment ever, unless, as Joe pointed out, there was a constraint that allowed the first node to fail and allowed the trie to check the second node. In the absence of a constraint, for matching purposes, these two nodes, ID and UUID, are identical for matching purposes. But if you recall, it's the musterman matcher itself that is the key in the dynamic collection. And so if I create two musterman matchers that are functionally equivalent, but just label the parameter with a different label as a result, those are two different musterman objects as far as musterman is concerned. So that means they're two different keys in our dynamic collection. Whereas if I use the same label, if I just asked it for a matcher for the symbol ID, musterman, to save resources, would try very hard to return me the same object if I asked for that again. And since it would return the same object, usually, no promises, then in the dynamic collection hash, you'd end up with the same key. And that means you'd be passed to the same node. So that is efficient in the old router. It saves on memory because every node that uses the symbol ID basically gets the same musterman matcher. So you create fewer musterman matchers, since that is likely to appear many times in different paths. And those are reused. So it was faster to compile for that reason, and also probably smaller in memory. Whereas once we put in our fix, now we were creating a musterman matcher for each complete route, which could potentially, depending on your use case, that could consume more memory. Does that answer your question? Did I talk around the barn?
That seemed your explanation seemed very clear to me.
I might have put them to sleep. All right, I'm happy to answer any other questions anybody might have based on my experiences with Hanami, or Dry-rb is a sister project of Hanami, as is ROM-rb. So based on my limited usage of them, if anybody has more general questions about that, I'd be happy to address them if I can.
I just want to sneak one question in real quick. At the beginning of your talk, you mentioned how you had gone about finding someone to work with on this. Can you just repeat that? Because that was interesting to me. I think this is I think anybody who's working in this field or wants to get more into open source, you know, contributions and things like that. This is a great inspiration for that, I think. And how did you go about finding a person to work with again? I know you mentioned at the beginning of the story of your talk, but if you could just if you don't
Sure.
mind sharing that again.
Well, I'm not afraid to say that my biggest bugaboo is imposter syndrome. So,
Me too.
I often have a hard time, jumping in, right? So I really wanted to help, but the idea of working on, a big library or family of gems like Hanami, like I didn't even know where to start. I didn't know how to open, the gem and read the code and understand it. I had done some contributions, so I guess I know the basics. I know how to open. I know how to look at and modify gems to try and analyze how they're working. And like I said, I've made a few small contributions, but they seem trivial to me. Whereas, jumping in on a big project like this, was scary to me. So, the answer to that in most cases is community. So, Hanami runs a discourse instance. That's their current forum solution. I know they're in the process of perhaps changing that, but that's what it is right now. And I've been involved in discussions over there, learning and trying to answer other people's questions. So I just made my own post saying like, look, this is who I am and where I'm at. I'd love to try to contribute, but I have a hard time knowing where to start. And, just ran a flag up looking for anybody else that was like-minded. So I got one response from a developer in Poland. That turned out to not be very workable. But this is Kyle. Kyle responded to me a little bit later, and he turns out to be in the same time zone here. So it was very easy to work with him. And we kind of hit it off when we spoke. So it felt pretty natural. And, one of his skills or positive attributes is like he has no fear in jumping in. So that was a good combination that I could sort of let him pull me in, and then once in, I found that I was able to contribute. I was able to understand what was happening, in this data structure in the router, and able to make contributions in that regard.
That's awesome, man. Thanks for sharing that. I'm looking for the Hanami Discord, and I see there's a few different ones, and I was going to post.
It's really in a state of flux. Because a lot of this work falls on Tim Riley, the gent that I showed you from Australia. He has a ton of excellent talks about his work in Hanami. And unfortunately, a lot of the work is falling on him right now. He actually just took the approach to leave his previous job and explicitly look for and find a new position where he would be allowed to work only 4 days a week so that he could dedicate the 5th day to work on open source projects. And he was able to find an employer to do that, and that's what he's been doing. But I'm pretty sure his current focus right now is a total like rebrand relaunch of those 3 families of gems, the Dry-rb gems, the Ram-rb project, and the Hanami project, under kind of one umbrella, so that we can have one forum, to find support, and one place to look, for a knowledge base.
So there is no. Would you recommend not to use the current Hanami Discord, or in the interim to use it?
People are there. I mean, it's the only solution in the interim. I don't know if he's announced a new thing yet or not. The only comments I've seen him made were that things were in progress. I follow him on Mastodon, and so the only public statements I've seen from him lately were around the progress that they're making on this.
Do you mind, since you would have it at your disposal, do you mind posting the Hanami Discord link
I think it's still linked from the homepage under community.
Oh, okay. Let me look there.
I think I just found it, so I sent a link just now.
Oh, beautiful. Yeah, I see. It is, and it is. It looks like awesome. Thank you, Charles. It's very cool. All right, so yeah, I'm gonna probably steal a page from that playbook. I think that's really awesome. I would love to get in and do some open source contributions. I think it's back to that.
Oh, thank you, Charles, for posting the Discord. Boy, I totally spaced on that. He actually
Oh,
did open the new Discord. So it is on Discord. Charles posted the link in the chat. I'm behind the curve, which is really silly because I'm actually on the new Discord. So I'm gonna chalk that up to the anxiety of presenting that I completely spaced on the fact that there is a new solution and it is Discord, and Charles has posted the link.
I thought that y'all were talking about Discord the whole time, and it was only now that I'm realizing you were talking about discourse. So
Yeah, so back then it was discourse. When I posted, looking for a compatriot in this, it was on discourse back then. And you can probably still access the discourse and even find my post. But Discord is the new gig. And there's already been a little bit of activity over there.
So it's just to make sure I'm clear. It's Discord is the newest, correct?
That is correct.
Okay.
In the chat, Charles has posted the correct link. And I posted the old link after him. So you don't want to go to the discourse. You want to go to the Discord.
Here's Damian's website. So yeah, thank you so much. I really enjoyed this talk, and it's neat to get into some of the nitty-gritty there and just to see. I think it makes things a lot more approachable to the fact that you would think that this would be a well sorted out problem, and you ran into it and took care of it. It's great for the community, and very interesting as well.
Well, the solution of using this data structure, I think, is kind of unusual. There are a couple of other really tiny projects that do something similar. But I thought it was a novel approach that Luca took and successful. The Hanami router is impressive.
So that was I didn't know anything about those details like Mustard Man and Roda. That was really interesting. Just to hear how. So Rails uses Mustard Man, is that right? Mustard Man, or correct
Yeah.
pronunciation?
So it's actually used in a lot of places. There are bash libraries that use it to process strings. It is used in frameworks in other languages. So at one time, I don't know if it still does, the Cake PHP framework project was using Musterman to match routes. It is configurable to some extent. So Sinatra uses a Sinatra configuration, and the people, I presume, on the Rails core team have created within Musterman a Rails version, is what they call it. So when you're actually creating a Musterman matcher here, you not only pass it that route string, but you would also pass it some options, one of them being a version, which is Rails. No, version is not the right word. I'd have to find it in the code. You pass it Rails, and then you pass actually a version number because Rails usage of Musterman evolved over time. So you pass it not only Rails, but a version number to get the correct implementation that you want. So the current Rails currently uses version like 5.0. They haven't made a change to the Musterman implementation for Rails since Rails was 5.0.
Oh, that's very interesting.
And their implementation is what allows them to do optional segments. If you've ever seen optional segments, they have a parentheses around them in the Rails routing definitions. And so the Hanami router actually uses that same Rails version of Musterman, and so can do some of the same thing. We haven't implemented optional segments yet, but we do have constraints available. So they're specified a little bit differently, but it's also possible to use constraints in.
Is anyone just that's in attendance using Hanami? Be interested to know. What do you please interrupt me. I know I'll fill dead airspace all day long, but please feel free to jump in and raise questions. I'm just curious, Damian, if when you got into Hanami, sorry, I mispronounced it a moment ago. Were you looking at Rails at the same time? Did you make a choice between one or the other, or can you talk about that journey a little bit if you don't mind?
Well, all right. I don't want to keep you here too long, but it's a little bit circuitous. So, my history, I've been using computers to solve problems for forever, and every job I've ever had, I was always looking for ways to use that tool to solve whatever problems that we had. So the first computer I programmed on was a TRS-80, back in middle school. I really thought I reached this like magnificent plateau when Microsoft Access was released, and I learned about relational databases and started building, little mini apps in Access. But I quickly found the limitations of that. I've worked in jobs where I had to, where I managed Salesforce projects. In a lot of ways, Salesforce seems to me to be the same kind of an evolution of Microsoft Access on the internet. This idea that your app is a layer wrapped around a database, and everything is in service to the database. And while I loved relational databases, that also felt very limiting and stilted to me. And so later on, I went to a boot camp, and the boot camp taught Sinatra and Ruby on Rails, and was centered around Ruby, but also included JavaScript. And so when I learned Rails, I loved it. I love the conventions that it provides. To me, Rails is possibly the most democratizing piece of software ever created. Like, I can't think of another project that made more possible, with so little friction. And so while I love that about Rails, it also seems to have this heavy bent, again, towards just wrapping database concepts. And you can see how they just map straight through the app, right to your routes. You see model names in your routes and columns in the dynamic segments, and that always felt weird to me, because I felt like I had grown beyond that, with finding the limitations of Access apps and Salesforce projects. And so I was looking for something that was built on some different principles. And when I found Hanami, and read the docs for the 1.3 version, it really felt like people that were trying to create the same kind of solution that I was looking for. So it felt like kindred spirits. So even though at the time I started my project, which I would like to be a real project, I mean, it's out in the world making tiny bits of money, even though I wanted it to be a serious project, I chose to use Hanami, even though at the time it really was just a router and actions, and views were just being developed. The view layer was just being developed at that point, and an actual proper persistence layer was still on the backlog. So you can say what you want about my judgment, but that's what I decided to do, was to use this project as a way to learn more about Hanami. And honestly, I haven't been disappointed. I really do appreciate the differences between Hanami and Rails and what it brings to the table. And one of those is, I think, that it's friendlier to ideas around modularity. And I can talk a ton about modularity, but for me, just to say this little bit, I don't see modularity only as a solution to managing massive code bases. I see it as a solution that can make even small code bases more maintainable. And so that's the way that I've been approaching, ideas in modularity and looking for how they could be implemented in Hanami. Because Hanami doesn't have a packwork, gem for it, but it does have constructs within the framework that help you organize your code into separate areas, which they call slices. So you can organize your code into separate slices, and you can, within Hanami, manage interactions between slices. So some of the basic tools from Packworks are built right into Hanami, and that's also appealing.
Thank you. No, that's very insightful, very interesting. Well, if anyone, if there are no more questions, I guess we can wrap the recording here.
Good. Thank you.
Um,
Thank you all.
So I will do that. Hang on, stand by just 1 second.